if you didn't get back 4 and you think you should have 4. But today we're going to talk final. And I have the final written, and I will put the hints for your class up in a bit. I did 3303 this morning. Their hints are up. So 3303 is all tidy. 3305, maybe tomorrow morning, maybe this afternoon. Depends on how crazy my office is. It was pretty crazy this morning. Lots of students realizing they're not going to get the grade they want. Indeed, they're not even going to pass the class. So in my role as cow catcher for the department problems, I have been gathering the unhappy students and dumping them in the incinerator. But, okay, there's 5 questions and an extra credit. Let's see, I think I gave you a time allotment on this. I try to anyway, usually. No? All right, question 1. Well, it's kind of on the big 3, hyperbolic, spherical, and Euclidean. What I have on the page are 10 statements, and there's 3 forms, and not much overlap on the forms. So it's more like 30 statements that I've ginned up. Some of them apply to all 3 geometries. What would be some things that apply to all 3? What's true in all 3? They have points and lines. They have axioms, theorems, and definitions. They have distance formulas. And then some of them apply to only, say, 2 geometries instead of 3. And I gave you a little code. You put HE if it's hyperbolic and Euclidean, and SE if it's spherical and Euclidean. There's some statements that are true in only 2, and then there's some statements that are true in only 1, but you have to pick which one. So if I say there are biangles, which one are you going to pick?
Spherical.
Spherical. So, and then there are some statements that are true in none of them, and you put a 0. So if I say something like, there are exactly 10 points in this geometry, well, that would be none of the 3, wouldn't it? Exactly 10? I'm thinking not. You know there's an infinite number of points and an infinite number of lines in all 3. Now here's one that's true in 2. Try this out and see if you get it right. The sum of the interior angles in a triangle is variable.
Oh, hyperbolic and spherical.
Hyperbolic and spherical. You can have different measures. They're different than Euclidean in 2 ways. One, neither one of them is 180. So I could have said the sum of the interior angles of a triangle is not 180 degrees. Hyperbolic and spherical. The sum of the interior angles of a triangle is not a constant. Again, hyperbolic and spherical. What are some other things that are true in all 3? Remember, I had to make up 30 statements for 3 forms of this. So I've got, huge numbers of things. So you go through, does everybody have, let's see, how about lines meet in 1 point only?
That's hyperbolic.
And Euclidean, right? Lines meet in 1 point. Lines intersect in 1 point. Hyperbolic and Euclidean. What about spherical and lines?
They meet at 2 points.
They meet in 2 points. So, there you go. That kind of statement, I state it just as a sentence. It's a declarative sentence. And you have to pick out which geometries it's true in. 3 of them, 2 of them, 1 of them, or none of them.
So
And I have
the hyperbolic can't be at 2 points, it's only at 1 point?
Lines meet in 1 point exactly in hyperbolic. So I've handed back the chapter 6 exercise, and and I will expect you guys to talk to each other about what things are true in 2 out of 3. And you can't just say this is true in 2 geometries. You have to say which 2. I've given you a complete code of what you say. 2, H-E. 2 of them, hyperbolic and Euclidean specifically. I'm picking out those questions. So that's going to be page 1. Page 2, question 2 is worth 24 points.
How many points for page 1?
2 points each, 20 points. So it's not like right or wrong. I mean, you can get quite a
Part of
few
it.
of them. I mean, it's graded individual sentence by individual sentence. Don't expect the grades back quickly on this. Matrices, 4 parts. A 4-part question, A, B, C, D. What kinds of things do we know about matrices? What can we do with matrices?
Add, multiply, scale factor.
Add, multiply, scale factor. What else?
Inverse.
Inverses. Find the inverse. How about find the transpose? How many people remember find the transpose? Yeah, see? What about using matrices? What do we know about using matrices? What do they do?
You can translate equations into matrices and solve.
You can translate equations into matrices and solve. You can use matrices to move geometric objects like triangles and circles around in the plane, can't you? And you can stretch and shrink geometric objects with matrices. So there'll be a part of this that is on using them to do something. So when you're studying, look at the doing. You know, what does it do to a triangle? Yeah.
For the matrices, do we have to solve for like the inverse? Are we gonna solve?
I will certainly have something like that on there.
So can we move the numbers around?
Move the numbers
Right.
around.
So like if you have 0, 1, 3, 1, 0, something like, can we move?
You
that
can
one
swap
zero?
rows,
Right.
if that's what you mean, and you can multiply a row and add it and then replace replace a row with a new row.
That's what I'm.
Yeah, those matrix, yes. Yes, you will have to do that.
If I solve it a different way, would you take points off the top?
Probably not,
Okay.
as long as the way is right. I mean, if you get a wild hairline and get original and creative and it's not true, I'm not going to give you any points.
Like as long as you multiply them, both the original and the new one, and get the identity matrix, that's your answer.
That's your answer. That's right. So matrices, you're going to have to do 4 things. I've got finite geometry for each version. You've never seen this geometry before, I'm pretty sure.
What's number 3?
This is number 3, question 3, geometries, finite geometries. So I will say this geometry has 8 points. I'll give you a set of axioms. None of the axiom sets are longer than 5. All of the points are under 15. So it's like, I'm not going to say this geometry has 780 points, draw a picture. You're in a time situation. It's not going to be 780. It's going to be something under 15, small. So you're going to have to look at the undefined terms, read the axioms, make a model on the paper of the geometry, and then answer 2 questions about the geometry in the test question 3, and then for the extra credit is asking you more things about that geometry that you got on your form. So in the extra credit, I'll say, look back at question 3, answer the following 2 questions. And that's your extra credit. So it'll be a new one. You've never seen it before. You know, there are 11 points, something like that. It'll start off telling you how many points, almost always. Yeah?
So you're going to give us one that we've never seen and we're supposed to draw it?
Yep.
Is it similar to like the spherical one that we saw or the
It's similar to the 4-point geometry that we saw and the 3-point geometry that we saw. So it's like those. We've worked with them, you know, yeah.
How many points is question 3 worth?
Question 3 is 16 points and the extra credit is 5 points, bringing it to 21 points for that. So these are all about the same weight, even though there's parts on some and not on others. Question 4 goes all the way back to isometries and similarities. It is a 20-point essay. You have to write to me about what I ask you with isometries and similarities. So you need to know some things about them.
Say that again. It's an essay about
About isometries and similarities.
and what about them?
I'm going to ask you a question about them that's a compare-contrast.
Okay.
So you need to know all of them, and you need to know qualitative facts about them. Not quantitative. I'm not going to give you a graph and say, apply this to this triangle. I'm going to ask you an essay question. Yeah,
How long does it have to be?
one sheet, front side only. So if you've got big fat handwriting, you better be very concise. Well, you know, the kind of girls that dot their I's with little hearts, that's big fat handwriting. Better be able to get it all on one page, front side only. Question 5, 20 points. One big picture question that starts in August and ends in December. Essay.
What? Say that again.
One big picture question.
Over
Essay.
It could be a
Over the whole semester.
what? Kind of like as a
We bring the essay in.
Just to tie it all together, big picture question.
what kind of question?
Essay question. One page, front side only.
over like the material that we've learned, or
Uh-huh.
like the
But it's a big picture thing. It's not details. I'm not going to say, where does this point go? It's not details. It's a big picture question.
Can you give us an example of a big picture question?
Yeah.
Can I?
Well, a good one would be, what is the purpose and result of the distance axiom in the 3 big geometries? What is the purpose of it?
So be a little.
What is the result of it? So you would need to be able to talk about the 3 different formulas in general terms, not details. General terms. What does that axiom give you that you don't get in, say, a finite geometry where there's no distance axiom?
I have no idea how to answer that.
Well, you'll
Honestly.
have, I should have worked this out. It's like 14 minutes per question. And you'll have 15 minutes to...
Could you answer the question you just gave us?
Sure. The purpose is so you can tell how far apart things are using a formula distinct to that geometry.
Okay. So just something that's simple.
Yeah, that's not, doesn't have to be, you've only got the front side of a sheet of paper, people. I'm not going to be
Okay.
asking you for a 3,000-word novel.
Can you say that question?
Right.
Example?
I said, what is the purpose and result of the distance axiom in the big 3 geometries? So that's the whole semester. We spent time on the distance formula since the beginning of the chapter.
And it's
We looked
basically
at the distance formula in 3D in chapter 1,
just to be able to.
just to be able to articulate some big picture idea about the class.
So that one would just be like to be able to get the distance.
By using a formula.
How far apart things are. And you might note for me that finite geometries don't have those axioms. Like the one in question 3, trust me, not one of those geometries has a distance axiom. Not one. You can't tell how far apart anything is in those little geometries that I'm giving you.
Oh, so you're just making up a type of.
Yeah, I just made it up today. It's not that question. That question's not on there.
So there will be a choice.
There'll be a choice? No. Each version has its own question. You don't have choices on which
Not
version
even in
you
the
get.
essays.
Nope, not even on the essays. So this is kind of different. You've got 2
I love when they do
essays,
something
a
different for the
brand
final.
new
So
geometry,
exciting.
matrices, that ought to be pretty straightforward. And then this business with the big 3 that we spent chapter 6 on.
Can you tell me how many points the matrices part one more time?
The matrices are 24 points total. I don't remember how I broke it out in the 4 parts.
What's number 3? The geometry.
Number 3 is 16 points, but there's 5 points of extra credit that goes with it. So the sum total on the new finite geometry is 21. Everything's about 20 points. But I thought,
So it comes out to 105 with the bonus. 105.
pretty much, yeah,
Okay.
yeah.
What do you, the extra credit on number 3?
The extra credit says, look back at your model and answer the following questions. And I have some questions there for you. That's all, just like straightforward questions. And you know how I grade. If your model's wrong, but you answer the extra credit consistent with your wrong model, you'll get all the extra credit points. You have to be internally consistent, though. If your model says one thing and your answer says something else, then no, we're not going to play with that. Then you don't understand your own model. But if you're consistent internally, then I'll go with that. You know. So gosh, guys, what else can I tell you other than the questions themselves?
The question.
Yeah, the questions.
Why not?
Essay question.
I got how many points? You've got 110 minutes on the test. Basically 6 questions, 110 minutes.
Can we do a matrix problem before we leave?
If you have one in mind.
What do you want to do, like inverse?
Yeah, inverse.
You want to do an inverse? Okay, let's do an inverse.
3 by
Yeah.
3, the hardest one.
No, it's not a 3 by 3, it's a 2 by 2.
Okay.
Okay, the exam, we don't have 3 by 2.
No, that was in the homework.
And then
I don't mind wasting your homework time, but I'm not going to put you in a timed test with a 3 by 3.
Okay.
Come on,
That's
be
great.
reasonable.
So only 2
What goes here?
2 by 2. So it's 2 by 2?
Yeah, it's a 2 by 2.
Oh, 2 by 3 versus
2 by 2.
2 by 2.
What are you?
Okay, what goes here?
2.
2. What goes here?
-2.
Negative 2. What goes here?
6.
6.
4.
Pi over 2.
No, not pi over 2. Thank you, Spencer.
Welcome.
Let's make it hard. All right, so our goal is 1, 0 answer, 0, 1 answer. Right? So the first thing you do when you read it, other than clutching your head and saying, oh my God, Miss Lee, how can you be so cruel? Is to write it down augmented. Right? Okay, now, we want a 1 here, don't we? And we want a 0 here. All right? How can I get a 1 here? Divide row 1 by 2. All right, so that's going to be 1 minus 1, 1/2, 0. And I want a 0 here. How can I do that?
Divide by 6?
No, that's going to give me a 1 there.
Sorry.
That would be, subtract 6 times the first one. Add 6 times the first one.
No, okay, so I'll come over here and use this row and say -6 row 1 plus row 2 is a new row 2. Are we all okay with that?
Yeah.
So that'll give me -6, +6, -3, 0, 6, 4, 0, 1. So that'll be a 0, 10,
Negative.
-3, 1. -6, row 1, this row 1, plus row 2, that row 2 is a new row 2. You okay with that?
When you're allowed to still keep the same row one.
Sure. What's the next step?
You get 1, 2, 0.
I want to get a 0 right here. How can I get a 0 right there?
Not add.
Well, the problem is if I add these two, I'm going to get a 9 there, right? I'm going to get a 9. How could I do something to this row so that when I add it, I get a 0
Add
there?
1/10 of row 2.
Okay, take 1/10 times row 2 plus row 1 equals a new row 1. Does everybody see that when I do that, I'm going to have 0, 1, minus 3/10, 1/10. And I'm going to add row 1. 1 minus 1, 1/2, 0. And I'm going to get, let's see, new row 1. I'm going to get a 1, a 0, a
Five.
-3/10 plus 5/10 is 2/10, 1/5, and a 1/10. What do I want right there?
1.
I want a 1. Didn't I do that when I multiplied 1/10 times row 2? So I've got a 0, 1, -3/10,
And 1.
1/10.
And there you go.
That's it.
Let's see, what did I do wrong? No, here it is. This is the matrix we want.
Yeah.
This is a 2 by 2 inverse. How do we check it? We multiply this one times this one.
So for the bottom here, where it says 0, 1, -3/10, 1/10, what are you doing to that right there?
1/10 row 2. 1/10 row 2. 0, 1, minus 3/10, 1/10. I wanted to get a positive 1 here so I could kill that negative 1.
Okay, but what is this 1, -1, 1/2, 0 under?
That's adding row 1 to it. Plus row 1 is a new row 1.
So you're doing 2 steps in one?
Yeah, pretty much.
Well, the 2 steps in 1 was when I declined to remultiply row 2 by 1/10 again. I said, we've already got it. It's right here. That gives me my 0, 1 right away. I don't have to write that down
And then you're
again.
adding row 1.
Then I added those 2 and I took the sum mentally and put it up here instead of copying it twice.
So we
0 plus 1 is 1. 1 plus minus 1 is 0. -3/10 plus 5/10 is 2/10 is 1/5. 1/10 plus 0 is 1/10.
So basically, if you multiply that one times those numbers on the right,
You'll get the identity matrix. Where's your question?
Why did you add row 1 to it after you multiplied?
Because I really, really, really want a 0 there. I want a 0 there. So I want to 0 out that minus 1. I want 1, 0, 0, 1. And what I'm stuck with is 1 minus 1. So I said, how could I get a 0 there? Well, get a positive 1 here and add them. That'll put a 0 right there. You want to see another one? All right.
Is it like, okay, so for the test, we're mostly gonna have to know the inverse?
You mostly know. Inverse is a possibility. 1 out of 4 things you have to know about matrices.
What are some of the other things?
Transform.
Transpose, can you do transpose?
It's just making rows to columns.
All right, what goes here?
1.
Don't make it too easy. How about
5.
5? And how about 10 here? And how about 3 here? And how about a 2? That'll make it real hard. So, I don't want a 5 there, I want a 1 there, right? And I don't want a 10 there, I want a 0 there.
2 row 1 minus row 2.
That would be 0.
2 row 1 minus row 2, and then it's always important to say where you're going is a new row 2. She noticed that if I multiply 5 times 2, I get 10 right here, and this is a positive 10, so if I subtract it, I will then have the desired 0 underneath my undesired 5. Are you okay with that?
Why would that be the new row 2 and not the new row 1?
You can choose which row you want it to be, and since she's going for a 0, she wants it down below. If she had said
The top one should
1/5 row 1 is a new row 1, then she's going for the 1 that goes here. Here's our goal,
Oh, so you don't always have to
a
start with that
1 and a 0.
We don't
No,
start.
you don't have to.
Oh, okay.
You don't have to.
It's easier though, right?
It's usually easier, but this one was not so bad as is. So you get to pick which one you replace, and you pick it strategically to give you a 1 here and a 0 here.
Let's try it that way since we did the other one last time.
You want to try it
No, the bottom
this
one.
way. 2 row 1 gives me a 10, a 6, a 2, and a 0, minus row 2. Okay, so as a new row 2, I'm going to have a 0, 4, 2, minus 1, and my same old row 1. Okay. Everybody okay with that? Wait, I'm not listening to you. Everybody okay with that?
Yes.
Some people who were saying yes, they wanted another one. Okay, so what's my next step?
Maybe 1/5
make
row
1.
1.
1/5 row 1. I really, really, really want a 1 there. I don't want a 5 there. So I'm going to write 1 3/5, 1/5, 0, 0, 4, 2, minus 1. Okay, now this one's a hard one. It's not at all obvious.
Row 2 divided by 4.
It's not at all obvious what I should do.
Row 1.
5.
How can I get a 0 there?
Row 2.
Multiply by 0.
No.
No.
Row 2 divided by 5.
Not quite. Let's look at this as an algebra problem.
Yeah.
See, I want 4 times something equals negative 3/5. Is that true? Is that what I want? So it's an algebra problem now. Solve for x. What does x have to be?
Negative 3 over 20.
Negative 3 over 20. How'd you like that one? Icky, icky, icky.
So row 2 times negative 3 over 20.
So, negative 3 over 20, row 2 plus row 1 is going to give me a new row 1 because it's going to zero this out.
So negative 3/20 times row 2.
Everybody okay with that? I'm not looking at you, Josh. Some people further back in the room, are we okay with that? You see how the mini algebra problem showed up? I really couldn't stare at it and say what to do. But I know what I want there. I want negative 3/5. Because I want it to add to 0. Now, one of the reasons that matrix work comes up right about the grades you're going to be grading is people have to become in charge of the problem. They have to know where they want to go and they have to make it happen. So that's what this is all about. This is not about seeing in any sense of the term. It is saying, I want a 0 there. What do I have to do to get a 0 there? And then you say, I want this to be that, solve for x. There it is. So if I multiply this times row 2, I get 0, negative 3/5, negative 6/20, and positive 3/20. Everybody okay with those numbers?
Wait.
Yeah. There will be a simple calculator on a link.
Thank God.
So, one's good. Oh, 2 times negative 3 was negative.
So then I'm going to add it to row 1. However, if you get off on the decimals, you're going to be in trouble because it won't multiply back. So I would advise you to keep with the fractions if you have this problem or one that's this tough. Keep with the fractions. So this will give me 1, 0. Now negative 6/20 plus 4/20 is negative 2/20
That's negative 1.
and 3/20. Questions? I'm looking at some specific faces. We all okay? Did I make a mistake?
Nope.
Is there something you're not seeing that you need to tell me about? Guys.
Yeah, and got a 0.
It's been a while. We've slept since then. We had a lot of turkey.
So does our row 2 stay the same?
Done a lot of homework
Still
since then
0,
too.
4?
Yes, our row 2 is not changed. Are you okay on row 1 now?
I seriously can't even think right now.
So are we done?
Nope.
What do we need?
One and one.
What have I got?
4.
What times 4 equals 1?
A 4.
1/4.
1/4. That's the same algebra problem.
1/4 row 2 plus
So
row
you
2.
say 1/4 row
one
2 is
equals
a
a
new
new row
row 2. And I'll just be happy with that. 1, 0, negative 1/10, 3/20, 0, 1, 1/2 minus 1/4. So there's my inverse matrix. And of course, checking it is matrix multiplication. But right here, people, this is really important. You know what you want. It's not at all obvious what you have to do, so the algebra should kick in.
There's no other way to do that part, right?
Mm-mm.
It has to be done where you multiply the bottom so you can add it to the top.
Mhm.
There's nothing you can multiply by.
You don't want to multiply the top because that would change the one that you want.
Right.
You want to use this because this is a 0, and when you add them, it'll stay 1. So you want to change this to 0 that out.
So there's no trig on the test at all.
Nope,
Good.
Phenomenal.
Lovely.
Makes me happy.
I could change it. if you
No, it's
want.
okay.
It's
That's
okay.
really okay.
It will do. It will do. Okay, if that will do. No, I figured there's plenty, we've got plenty of that. We've had plenty of that.
Yep.
What's an example
I
of
could
the
do without that.
transpose?
Except that might have an easy trick.
If you transpose a matrix,
No.
you turn the columns into rows, or the rows into columns. Transpose. Look it up in the index. There's a couple of examples.
So if you're gonna study for this test, would you lean more on the book, or would you lean more on the activities? Or would you lean more on...
I'd lean pretty hard. I'd divide my time between the topics in the book. I mean, specifically look up isometries and read about isometries. Look up similarities and read about similarities. The book and the activities. Just divide your time. But don't sit down and reread the book. I mean, there's a lot of stuff in the book I've specifically not mentioned because it's not there. Yeah. No 3x3 matrices on there at all. All the matrices are 2x2. I am painfully aware that you have 110 minutes only. If you overrun, you will be escorted out. You cannot keep that seat, someone else has it. So, you know.
Just one suggestion that I've noticed in my few years going to there. They really need to stop forcing us at the very beginning. As soon as we sit down, okay, go log in and start. Because I mean, it doesn't take but a minute just to go ahead and just flip through, make sure you got the right booklet. Because I have gotten there once and I did have the wrong booklet, and I didn't realize until the end that it was for the wrong class. So they still took it, and everything was fine. But I mean, if they wouldn't have, they really don't need to pressure you so fast at the beginning. Let us check
I'll tell their manager.
and don't, because I mean, it would be lovely just to look at the booklet. Okay, here's how much of everything I got. Make sure I have everything. Write my name on it. Just do the simple stuff.
Okay, I'll pass that along.
Yeah.
Other questions? All right, now people, I've got some papers up here. Brianna, Ivan, here's one for Ivan. Victoria, Efren, I've got some of yours. Rodrigo, Kevin, Tiffany, I've got a bunch for you. Danielle, Riandria, Amanda, I've got some more for you. Andrea Senor, there's 4 piles.